Hello everyone, this is Jyotsna. Welcome back to my YouTube channel. In this tutorial, we will see the design pattern factory method. So let's start first with what is exactly is design pattern and what are the different types of design pattern. So design patterns are reusable solution to common problems that arises during software design or development. These patterns provide general solution guidelines and template to help developers solve recurring design problems in their software application. So according to Geo design patterns, there are three main types of design patterns: creational design pattern, structural design pattern, and behavioral design pattern. So the creational design patterns deals with the process of object creation, structural design patterns deals with the composition of object structure, and behavioral design pattern deals with the process of communication, relationship, and responsibilities between objects. So there are different types of these main patterns also, like there are different types of creational design pattern, structural design pattern, and behavioral design pattern based on the definition of each design pattern. So today we will see one of the type of creational design pattern. So if you see, there are five main types of creational design pattern: singleton, factory method, abstract factory, builder, and prototype. So today we will see the factory method design pattern. So first let's start with the problem statement. When we design our system, there are some point where we face some problems while designing the system. So there are some type of systems when we want to design. For example, here I am giving one example of logistic application. So imagine that you are creating a logistic management application, and initially the only one mode of transportation you are using, which is by road, means by truck. Here you can see that one example I am giving here. So when I'm designing the system, my all code will be added within that particular truck class. Now when my app becomes popular, so I am getting like new requests to add the another mode of transportations, like by sea or by air, like that. So at this point, most of my code is tightly coupled with this truck class, and adding any new modes of transportation like by sea, means by ships or by airplane. So that would require making changes to the entire code base, because previously I did write code based on my requirements for only one mode of transportation. Now, if we later decide to add any other type of transportation, I have to make all the changes again. So as a result here, my code becomes messy. So it's filled with conditional that switch conditionals which I need to use for in the app behavior depending on the class of the transportation objects, and this will create a maintenance issue. Also, it will reduce the scalability of the application. So what to do in this case? The solution is factory method design pattern. So how do we use that in this problem? So with factory method design pattern, it will help us to decouple the client code from specific transportation type. So here the transportation is an interface which will have the deliver method, and we will have the concrete classes which is like truck or ship or airplane if there is any other mode of transportation added. So that will implement this transportation interface. Now here we will also have the transportation factory interface with the method of create transportation to instantiate our transportation objects. And we will have the concrete factories also, like truck factory or sea factory, something like that, or ship factory or airplane factory, that will return the corresponding transportation objects. We will also have the client code which will interact with the factories, not the concrete classes, because here we are interacting with the factories in client code and making it easy to add a new transportation type without modifying existing code. And with this approach of using factory method design pattern, we will have the flexibility, scalability, and decoupling of the system. And it will also allow the future extension without changing the existing code base. So this is one of the solution of using the factory method design pattern we can use to solve our problem here. So let's start with some introduction or the definition for the factory method design pattern. So factory method design pattern, also called as virtual constructor. As I said, this is a type of creational design pattern and it provides an interface for creating objects, but here we let the subclasses alter the type of object that will be created. And also here, instead of directly instantiating objects within a class, the factory method delegates the responsibility of creating objects to its subclasses, allowing the subclass to be more flexible and decoupled. So this is the main importance of using factory method design pattern. Let's start and see what are the different uses when we use the factory method pattern. So this is the most beneficial in scenarios where object creation involves complex processes or when the exact type of object to be created is not known until the runtime. That time we can use the factory method pattern. So there are some other uses also I have listed down here. The first one is when the exact type of object is determined by subclasses. So how? If you have a class that needs a object creation, but you want to leave the decision of which class to instantiate to its subclasses, that time we can use the factory method pattern. Also here, the base class defines the factory method and subclass implement this method to create a specific object. One of the example I can give here for document creator. So for the document creator, we will have one class document creator that might need to create a different types of documents. Example PDF or Word document. But the type of document is not known until runtime. So what we'll do, subclasses of this class document creator can implement the specific creation logic for that document. Then next is when object creation logic is complex or needs to be separated. So if the creation of an object is complex or involves several steps, the factory method pattern allows you to encapsulate this complexity in one place, that is concrete creator, and this will keep the code clean and separate, right? So here one of the example for this is like creating a product that involves setting up configuration or dependencies like connecting to a database or network. So here the encapsulating this setup in a factory method can help manage the complexity. So third one is when you want to provide a uniform interface for creating objects. So here if you want to ensure that all objects are created in a uniform way using a factory method, so the base class can provide a consistent interface for creating products. So even though different subclasses may produce different types of products. So for this, one of the example is UI component factory. There we may create a various type of buttons, like we need Windows button or Mac OS button, but you can ensure that all button types implement the same interface, that is button. So the creation is abstracted away from the client. The fourth one is when you want to allow for an easy future extension. So here the factory method allows new type of objects to be added with the minimum changes to existing code. And if the new type of products are introduced later, you only need to add new concrete creators and products without modifying the core logic or client code. Next is when you need to avoid tight coupling between client code and concrete classes. If you want to decouple the client code from concrete classes, the factory method allows the client to interact with product and interface or abstract classes rather than directly dealing with the concrete classes. So that will also make the code more flexible and easier to maintain. One of the example is like document processor class, and we may need to work with different types of documents like PDF and Word. But using the factory method, it doesn't need to know the concrete classes and only interact with the document interface. The next is when you want to support product families or product variations. So here if you have a set of related products that share a common interface or class but different in implementation. So that time the factory method allows you to provide different families or variation of the product. The next is when you need to manage object life cycles and ensure proper initialization. So here the factory method pattern can be useful when you need to control the life cycle of initialization of the object. And the method can contain logic to ensure that objects are correctly initialized or configured before use. So these are some of the uses when we use the factory method pattern. These are some of the applications for the factory method design pattern like UI frameworks, database connection factories, login frameworks, document generation system, game development, network protocols, and file processing system. One of the example for UI frameworks is like we have to create a cross-platform specific components different for different operating system, and they might have their own way of rendering button, text fields, or other UI element. That time we can have the factory method design pattern where the factory can abstract away this platform specific logic, making it easier to work with a common interface while still supporting different platforms. For the database connection factories, one of the example is like we have the connection factory which can be create appropriate connection object depending on the type of database. Like if you want to use Oracle database or MySQL database, so based on the environment or the type of database, we can have create the connection factory. For example, a factory method might be used to instantiate a connection object, but the connection implementation would vary depend on the database which is running on cloud or local server or some other environment. So this is one of the example for this. So likewise, these are some of the application for the factory method design pattern. So this is a generic class diagram we can see here. So there are 5 different components actually. 4 are given here. Fifth one is a client component. So first one is like product, then concrete product, second one. Then we'll have the creator and then concrete creators. Fifth one is client. So these are some 5 main components of factory method design pattern, and this is the generic diagram using that components. So we have the product interface, which will have it might be interface or abstract class. And then we will have the different concrete products which will implement that interface. We have the creator class with some methods, and those that will be abstract class, and then we will have the concrete interfaces, concrete creators for that creator class that will also implement those methods. Let's explore all these components one by one here. So first one is product, which I said it might be abstract product. So this defines the interface or abstract class that the concrete product classes will implement. The purpose of this component is to ensure that all product types created by different concrete creators shares a common interface or behavior. So here making it possible for client code to interact with them interchangeably. And one of the example is document creation system where the document class could serve as a abstract product. So concrete product which will implement this product, abstract product or abstract interface, and it represents the different types of products that can be created. Here each product class corresponds to a specific implementation of the product interface. And purpose of this component is to define the specific details of the object created by the factory method. One of the example is if we are dealing with the documents, concrete products could be classes like PDF document or Word document. Now third component is creator, which is also abstract creator. Here the creator class declares the factory method, which is intended to be overridden by subclasses, and it may also contain some default behavior or logic, but the actual instantiation of a specific product is left to its subclasses. The purpose of this creator class is that it provides a template or blueprint for the object process creation. It defines the factory method but leaves the actual instantiation of the specific product to its subclasses, allowing the flexibility in the object creation. And for the same example, we'll have the document creator class could be a creator with the create document method as the factory method. The next is concrete creator. So this class will inherit from the creator class that implements the factory method. These classes are responsible for creating specific instance of the concrete products. Now, the purpose of this component is that where the actual logic for creating products is implemented. So it overrides the abstract create document method from the creator and returns instance of a specific product. So example PDF document or Word document product. So the same example is given here, like class which is a PDF creator or Word creator would be implemented in this logic. Now the last component is client. So it is responsible for creating or interacting with the creator class and utilizing the factory method to get a product. So here the client does not need to know the exact type of product being created, only that it conforms to the product interface. The purpose of using this that it uses the factory method to instantiate products without being tightly coupled to concrete product classes. So here we are using the loose coupling between the classes. And one of the example is that user might request a document creation from the factory. That is means client code, which is our PDF creator. And the client code would simply interact with the document interface, not worrying about the PDF document or Word document. So these are the 5 main components of the factory method design pattern. So there are some advantages and disadvantages also while using the factory method design pattern. One of the is decoupling. So as I said, factory method gives the decoupling advantages. How do we do that? So here the factory method decouples the client code from the concrete classes of the product, and the client only interacts with the product interface, making the system more flexible and extensible. Here also the client doesn't need to know with a specific class is being instantiated, just that it adheres the product interface. So this is one of the very important advantages of using this design pattern. The another is flexibility in object creation. So here it provides the flexibility in creating different types of objects based on the runtime conditions. It also, by overriding the factory method in subclasses, you can easily control which concrete class gets instantiated. The third one is, so this is easy to add new product. This is the third advantages. So when we product type can be we can add a new product, right, in the same application. That time we don't need to change any existing code. We can simply add by creating new concrete product, and the corresponding concrete created you can extend the system. Here the subclasses or the concrete class or the creator class can implement new product without affecting the other part of system. The next is code reusability. So factory method centralize the object creation logic. If the object creation involves complex initialization or setup steps, this logic can be reused across the system. So giving it as a code reusability. So this is one of the advantages of using factory method design pattern. Another one is encapsulation of object creation logic. So here the complex logic of object creation can be encapsulated within the factory method, making it easier to maintain and modify in the future. There are some disadvantages also using this design pattern. One is increased complexity. Here, when we use this pattern, we introduce additional classes, like we introduce abstract creator or concrete creator classes, and that can lead to increased complexity in the system. So the abstraction adds the layers of indirection that may not be necessary for a simple object creation. That time it will increase the complexity. So more classes. So each new type of product requires creating a new concrete product and a new corresponding concrete creator. So that will be like more adding more multiple classes. So this is one of the disadvantages. Then in difficulty in understanding. So sometimes what happens for developers unfamiliar with the factory method, it can be harder to understand how object creation works. So the indirection of the factory method can make it more difficult to track down where objects are being instantiated. Next is overhead for simple cases. So in scenarios where the object creation is straightforward and does not involve complicated logic or variations, using the factory method design may introduce unnecessary overhead. Then dependency on subclasses. So if the factory method is overridden in subclasses, the client code may become dependent on specific subclass implementation. So if the subclass hierarchy changes, it could lead to an issue or requirement modification in existing code. And the last one is potential for code duplication. So in some cases, what happens, multiple concrete creators may implement very similar logic for creating different product types. So, and this could lead to code duplication where each creator has redundant code of constructing products. So these are some of the disadvantages of factory method design pattern. So in this tutorial, we have only seen the theoretical part, means what is factory method design pattern, what problem statement it solves by giving the solution, some uses and application, and advantages and disadvantages with us explaining the diagram for the factory method design pattern. So in our next video, we will see the one of the implementation example for the same. For this is it for now in this video. Thank you so much for watching.